Hello, hello, hello. Yes, good afternoon, everyone. Let's start a revision class regarding kinematics, motion as straight line and motion in a plane. We will discuss a brief revision class from those two topics, from those two chapters, from the concepts of NEET. So, when it comes to the NEET point of view, it's very important to understand the concepts. Like there are high weightage, moreover, sorry. So we have a high weightage regarding these concepts and these chapters. So let's have a quick revision regarding all the topics from these chapters. So, so mainly when we talk about the concepts of kinematics, there are some terms which you need to remember, like what is meant by position vector, what is meant by displacement, distance, velocity, as well as acceleration. So let's start what will be the idea, and then let's go for the numerical aspect. First, let's see what would be a vector, precisely position vector. So let's assume we have a coordinates. Let's take it as y-axis as well as x-axis, and let us consider there is a point. Let's take it as x comma y. So we need to write down what will be the position vector at this point. So here position vector is nothing but a vector drawn from the origin to given point. So let's take a vector now. So take a vector from the origin to this point, and this vector is known as position vector. So if you want to write this position vector, let's denote this position vector as r bar, such that r bar would be, so here x is nothing but length along x-axis, and y represents the length along y-axis. So unit vector along x-axis would be I cap, and unit vector along y-axis would be j cap. So this position vector can be written as distance along x-axis and its direction plus length along y-axis and its direction. So this would be the representation of position vector. So if you consider z axis, then you can take a position vector along z axis would be k cap, and we can write the position vector accordingly. So with the idea of position vector, let's try to discuss what would be the displacement vector as well as distance. So let's see what is meant by distance as well as displacement. So in general, distance is nothing but a path length. So here distance represents a path length. So for example, we are starting at point A and we reach towards point B. So distance would be the total length covered from point A to point B. So when we are going to find the distance, we should consider the total length, and most precisely this distance would be a scalar quantity in which this values is always positive, as well as some conditions it can be 0 also whenever there is no path length. Or when we consider a displacement, so displacement is nothing but shortest path covered in a journey. So let's assume, let's take a same example. There is a point A and point B. You are moving from point A to point B along this path. So if you want to find the displacement, we should consider a shortest path, where the shortest path is always a straight line joining 2 points. So we need to consider displacement will always be a straight line because it would be a shortest path when you are going to consider any 2 points. So if you consider at point A, or let us consider point A is at one position, let's consider its coordinates as x1 comma y1. Similarly, point B is at one of the position, let's consider its coordinates as x2 comma y2. Let's assume it is in the coordinate system. Now I need to find it out what will be the displacement and how to represent the displacement. So here displacement is represented as delta r, such that this displacement vector delta r would be equals to change in the position, which can be considered as final position minus initial position. So it would be a final position minus initial position. So delta r would be equals to final position can be considered as x2 comma y2, and initial position can be considered as x1 comma y1. Since this is a vector quantity, we need to consider their coordinates. So we can consider this change in position is acting along x-axis as well as y-axis. So this position vector can be considered separately for x as well as separately for y, such that this displacement vector would be equals to change in position along x-axis and change in position along y-axis. So such that the displacement vector would be equals to change in position along x-axis would be x2 minus x1, and direction would be I cap, and change in position along y-axis would be y2 minus y1, and the direction would be j cap. So this is a formula to find the displacement. So whenever you are writing this displacement in the vector system, so we can tell this displacement would be a vector quantity. Such that the values of displacement can be positive. So this displacement can be positive, it can be negative, as well as it can be 0 also. So distance can be only positive or 0, but displacement can be positive or negative, even it can be 0 also. So let's try to understand another quantities like a velocity as well as acceleration after completion of this example. So in this example, the given a car is moving from O to point D in along a path O A B C D shown in the figure. What will be the distance travel and what will be the net displacement? There are two questions which we need to find the distance as well as displacement. So here distance is nothing but total path length. So initially we are at point O. Now we are going to point D. So we need to consider the total distance from point O to point D. So here total distance would be a total path, such that from point O to point D, first we started to go from point O to point A. So it would be path from O to A. again path from A to B, again path length from B to C, again the path length from C to D. So the length from O to A is given as 8 kilometers. The length from A to B is 4 kilometers, and from B to C is also 4 kilometers, and from C to D it is given as 1 kilometer. So the total path length would be 8 plus 4 plus 4 plus 1, which would be equals to 17 kilometers. Then let's find it out what will be the displacement. So to find the displacement, we need to consider a shortest path. So initially we are at point O. Now we are going to point D. So the shortest path from point O to point D would be a straight line joining O to D. So we should find what will be the distance from O to D. Let's put this as x. So we should find the displacement. So here displacement is x, which we have been assumed. So to find the displacement, let's see what are the known quantities. So here from point O to point A, total length is given as 8 kilometers. From point C to point B, they have given the total length as 4 kilometers. So let's try to extend this straight line. So if total length is 8 kilometers, from the distance, let's assume this as point E. So distance from C to B is 4. Since we are drawing a straight line parallel to AB, so distance from C to B would be same as distance from E to A. So its length would also becomes 4 kilometers. So the total length from O to E would be equals to 4 kilometers as well. So this would be 4 kilometers now. Now to find the value of x, let us use the concept of Pythagoras theorem, because this would be a right angle such that O to D would be a hypotenuse for this triangle O, E and D. So to find the value of x, first we should know the length from D to E. To find the length from D to E, let's draw another parallel line of CD such that if you consider the length from C to D as 1 kilometer, and if you put this point as F, distance from B to F would also be 1 kilometer. So if distance from B to F would be 1 kilometer, so distance from F to A would be 3 kilometers, because total length from A to B is 4 kilometers as per the given question. And since this line CE as well as AB are parallel to each other, so distance from F to A would be same as distance from D to E, which would be same as 3 kilometers now. Now when we look at this triangle, so when we observe this triangle OED, this OE is given as 4 kilometers and ED is given as 3 kilometers. We need to find this length from O to D, which we have been assumed as x. So according to Pythagoras theorem, this value of length would be equals to 5. So the displacement would be equals to 5 kilometers. So this is how we can able to find the values of distance and displacement from the given questions. So you can check it out, and if you have any doubts regarding these concepts, you can put in the comments also. Now everything is fine, I guess. Now let's try to see what will be the speed as well as velocity. Now here let's understand what is meant by speed, and again we can discuss what will mean by velocity on this side also. So here speed is nothing but total distance upon time taken. So where this speed would be a scalar quantity, because it is depending upon distance, which is also a scalar quantity. When I take a velocity, velocity would be equals to displacement upon time taken. Since displacement is a vector quantity, so this velocity would also be a vector quantity. So let's try to find it out. What will be the value of speed and how to find the value of speed and what will be how to find the value of displacement. So since a speed is a scalar quantity, let's name the speed, let's denote the speed as v. Since velocity is a vector quantity, let's denote the velocity as v bar, showing bar represents the vector quantity. So to find the velocity, here velocity is nothing but displacement time taken, where displacement is nothing but change in the position, and time taken, let's take it as t. So from here, velocity would be equals to change in the position means displacement divided by time taken also. So this would be the formula to find the velocity. So let's see a few cases how to find the velocity, where we are using the position terms. From the positions, let's try to find what will be the average velocity. Similarly, let's try to find it out what will be the instantaneous velocity. So here, since we are taking the change in the position with time taken, this velocity can also be considered as average velocity, such that the average velocity would be equals to change in the position divided by time taken. And if you want to find the instantaneous velocity, here instantaneous velocity would be velocity at that particular instant of time. So let's say we are moving from one point to another point. So in the way of moving from one point to another point, we may increase its speed or decrease its speed, or the velocity can increase or decrease. If you want to find the velocity exactly at one instant, let's say you are moving from one point to another point and you took 5 minutes to reach. If I want to find velocity exactly at third minute, in that cases, at that particular instant of time, if they are asking us to find the velocity, we can use instantaneous velocity, where the instantaneous velocity would be equals to differentiation of position with respect to time. So dx by dt would be the formula to find the instantaneous velocity. So we took x. If there is a change in the position along x-axis, if you take there is a change in the position along x-axis, y-axis and z-axis, instead of taking x, let's take it as r, where r would be the position in 3 dimensions. Or if you take there is a change in the position only along x-axis, we can directly mention it as dx by dt. So let's try to understand few important terms where you need to remember. The first important term is the distance can always be greater than or equals to displacement. So displacement is a vector quantity which has positive, negative and zero values. Let's mention it as magnitude, such that we can compare the values also. And in the same way, a speed would always be greater than or equals to velocity. If I am mentioning about speed or velocity, remember this would be the average speed is always greater than or equals to average velocity. If you want to represent, just represent the terms. The average speed would always be greater than or equals to average velocity for a better understanding. Because distance and displacement can vary, so average velocity and average speed can also vary. But the most important point, this instantaneous speed is always equals to the magnitude of instantaneous velocity. So average speed and average velocity can vary, but the instantaneous speed and instantaneous velocity is always same when we are going to consider its magnitude. So very important in terms of conceptual terms. So try to remember these two cases. So let's see one example where they have given the position. Accordingly, we need to find the average velocity as well as instantaneous velocity. So let's see one example also. Let's take we have a position vector where the position vector is given as 2t I cap plus t square j cap minus 4. This is a position vector where when the time gets progressed, the position is also going to change accordingly. Our question is, we need to find it out. What would be the velocity from 0 to 2 seconds, as well as we need to find the velocity at 2 seconds. So we have two questions. We need to find the velocity from 0 to 2 seconds, and we need to find the velocity at 2 seconds. So if you observe, they haven't mentioned whether we need to find average velocity or we need to find instantaneous velocity. But looking at the time intervals, you need to understand what we need to find it out. Since I mentioned a duration from 0 to 2, so we need to consider, we need to find the average velocity. But in the second case, they are asking us to find the velocity exactly at 2 seconds. Means they are asking us to find the velocity exactly at one time interval or particular instant of time. So we need to find the instantaneous velocity for this case. So let's look into the first question. They are asking to find the average velocity from 0 to 2 seconds. So let's try to solve this question. So first, the average velocity is nothing but displacement divided by time, or we can take displacement by time, where displacement is nothing but change in position. So if you want to find the displacement, first we should find the change in the position. So here the position is varying only along x-axis, so delta r would be equals to final position minus initial position. So here final position is nothing but position of the body at 2 seconds. Initial position would be the position of the body when it is at 0th second. So since the time intervals are varying from 0 to 2, we can consider t1 would be equals to 0 and t2 would be equals to 2 seconds. So if you want to find the final position would be a position when time t is equals to 2 seconds. Initial position would be a position when time t is equals to 0 seconds. So we have a formula of position where x is equals to 2t I cap plus t square j cap minus 4. So final position would be equals to position when time t is equals to 2 seconds. So this would be 2 into 2 I cap plus 2 square j cap minus 4. This would be equals to 4 I cap plus 4 j cap, and this would be the value of position. So try to remember, since they given some direction that is along x-axis as well as y-axis, we can put the value accordingly as delta x as well as delta y. That is also fine. This x and y is just a notation along x-axis and y-axis. So we can consider delta r would be x final minus x initial or r final minus r initial also. So similarly, when we take a initial position would be the position when time t is equals to 0 seconds. So initial position would be final position minus initial position, which would be equals to position. Let's write the position, final position, we got it out. Let's take the initial position. So initial position would be a position when time t is equals to 0 seconds. So initial position would be equals to, let's take the position vector as 2t. So 2 into 0 I cap plus 0 j cap minus 4, which would be equals to minus 4. Now we need to find the change in the position. So from here, change in the position would be equals to final position minus initial position. So final position we got it as 4 I cap minus 4 j cap minus 4, and initial position we got it as minus 4. So plus 4 minus 4 gets cancelled. So change in the position would be 4 I cap minus 4 j cap. I think direction along y-axis is positive, so let's mention it as plus. So since we got the change in the position as 4 I cap plus 4 j cap, so the average velocity would be equals to 4 I cap plus 4 j cap, and time is varying from, they given us 0 to 2 seconds, so it would be 2 minus 0, which would be equals to 2 I cap plus 2 j cap. We can see there is a change in the position both along x-axis as well as y-axis. So change in the position in this case would be 2 I cap plus 2 j cap. Sometimes there will be a questions where direction can be varying only along one direction. Like if they given in only one direction, like r bar is equals to 3 t minus 2. Or we can see they haven't given anything about the direction, so there is a variation only along one direction. But in some cases or in some instance, they will give there is a change in the position along x-axis as well as y-axis. In that conditions, you should take x-axis separately, y-axis separately, or you can both combine at a single time, but you should take a positions accordingly and try to solve the question. So let's try to understand. We can solve the particular example only both in two directions as well as one direction. So try to observe which case they are precisely talking about. Okay, we got the value of velocity, that is implies average velocity, which is 2 plus 2 j cap. Similarly, let's try to find it out what will be the velocity at 2 seconds. Means they are asking us to find the instantaneous velocity at 2 seconds. So let's try to solve that question now. So to find the instantaneous velocity, so instantaneous velocity would be a velocity exactly at that particular instant of time. So v would be equals to differentiation of position with respect to time. So why we are not putting dx by dt? Because here there is a variation both along x-axis as well as y-axis. So we need to consider both along x and y. So let's try to find it out. So v would be equals to d by dt of, so position. So here position is given as, what is the value which they given? 2t I cap plus t square j cap. So 2t I cap plus t square j cap and minus 4. You can take the direction, or if they haven't mentioned, means we are starting this from a different position, not exactly from the origin. So let's try to sign it out. So v would be equals to differentiation of 2t would be 2, and differentiation of t square would be 2t. So put the directions, and differentiation of constant becomes 0. Now, since they are asking us to find the velocity exactly at 2 seconds, so when we put at t is equals to 2, then velocity would be equals to 2 I cap plus 2 into 2 j cap, which would be 2 I cap plus 4 j cap, and this would be the value of instantaneous velocity. If they're asking us to find the magnitude, so the magnitude v would be equals to under root of 2 square plus 4 square. Accordingly, we can able to get the answer, which would be 4 plus 16, which would be equals to under root of 20. So this is how you can able to find the average velocity and instantaneous velocity depending upon the values which have been given. So try to check it out, and which would be one of the important concepts which they would be using frequently. And then let's talk about another important case, that is finding the average speed in a journey from one point to another point, where they will be asking us to find the average velocity. Sometimes they can give time intervals would be same, sometimes they can mention distance would be same, instead of giving the time intervals as well as distance. Let's see a question where you can understand these concepts a little more detailed also. The question is, a body starts from point P to a point Q. So you are starting from point P to point Q such that the body, so that body moves, or that body moves from P to Q with a speed of v1 and v2 in two equal time intervals. So we need to find it out average speed. So look at the question carefully. So we are starting from point P and going to point Q. So they given a body is moving from point P to point Q with the speeds v1 and v2 for two equal intervals of time. That implies, let's assume till this point, assume this point is r. From P to R, let's take the speed is given as V1, and from R to Q, the speed is given as V2. The only thing they have been mentioned is time intervals are same. We need to find the average speed. So to find the average speed, the general formula to find the average speed would be equals to total distance divided by total time, but distance as well as time they haven't given. So let's assume from point P to point R, distance is x1. From R to Q, distance is x2. Assume the time intervals from P to R is t. Time taken from R to Q is also t, because time intervals are same. So from here, total distance would be equals to x1 plus x2, and total time would be t plus t, which would be equals to x1 plus x2 divided by 2. But x1 and x2 are unknown for us. So we should find the values of x1 and x2 in terms of known values called v1 and v2. So for this case, we can use the formula of speed as speed is equals to distance upon time. So from point P to point R, speed is given as v1. So v1 would be distance from P to R would be x1, and time is given as t. So from here x1 would be equals to v1 into t. Similarly from R to Q, total distance would be equals to v2 into t. So we got the values of x1 and x2. Let's put the values into this equation. So we will get the value of x1 as v1t, x2 as v2t divided by 2t, which would be equals to v1 plus v2 whole divided by 2. This would be the average velocity whenever the time intervals are same. Similarly, the same idea we can use whenever the distance traveled is also same. Let's have an example also. Let's take an example. A car moves from point P to point Q with speeds v1 and v2 in equal, or we can take in equal distances. Or sometimes they can frame the statement in another way. Like a body is moving from point P to point Q, half of the distance will be traveled with speed v1, another half of the distance will be traveled with speed v2. Both statements are completely valid. So in that case, we need to find the average speed. We need to find the average speed. So to find the average speed, we can use the formula v is equals to distance divided by time. Let's assume we are moving from one point to another point, like from point P to point Q. So they given the speeds as v1 and v2 respectively. Let's put this point as r. Now our idea is to find the value of average speed. So to find, we need to find the distance as well as time, which we don't know for us. But they given only one term, that is distance are same. So let's assume the distance from P to R as x, distance from R to Q is also x. Assume the time intervals are t1 and t2 respectively. So to find the total distance by using this formula, it would be x plus x, and time taken would be t1 plus t2. Since time is unknown for us, we can use the formula speed is equals to distance divided by time. So from here time would be equals to distance divided by speed. So from P to R, time interval is t1, that would be equals to distance, which is x, and the speed is v, so we can take it as v1. Similarly from R to Q, time would be equals to distance divided by speed, so distance would be x and speed is v2, so we'll get the values of t1 and t2. Let's put the value over there. So speed would be equals to total distance divided by total time, that is x by v1 plus x upon v2. So this would be equals to 2 into x divided by, let's put the value of x outside, which would be 1 by v1 plus 1 by v2. So x will get cancelled from two sides. So the answer would be 2 into v1 v2 divided by v1 plus v2. So in that question, if they mention distance is same, so the average speed would be 2 v1 v2 by v1 plus v2. Or if they mention the time intervals are same, then average speed would be just v1 plus v2 divided by 2. So try to check it out, these concepts, which is quite important. for exam point of view. Check it out. If you have doubts, you can just let me know in the chat also. Then let's see another concept, or let's do an example also. In that one of the example they given, a car is traveling half of the distance with a constant velocity 40 kilometers per hour and the remaining half with the constant velocity of 80 kilometers per hour. Find the average velocity of the car. So we discussed in terms of speed. So the same we can do for average velocity also. They mention half of the distance with the speed 40 kilometers per hour and remaining half of the distance with speed 80 kilometers per hour or velocity 80 kilometers per hour. So since they given the distance or displacements are same in this case, so we can use a formula. The average velocity would be equals to 2 v1 v2 divided by v1 plus v2. So since they have been mentioned the distance are same, so we can directly use the formula for average velocity as 2 v1 v2 by v1 plus v2, which would be 2 into 40 into 80 divided by 40 plus 80. So which would be 2 into 40 into 80 upon 40 plus 80 would be 120. So we can cancel with the zeros, 4 twos or 4 threes, which would be equals to 2 4 4 4 16, 160 upon 3. Units are given as kilometers per hour. So 160 upon 3 would be closer to 53.3 kilometers per hour. So this would be the answer for this particular question. So once try to practice out, which would be helpful for you. Okay. So we got an idea how to find the speed and velocity. Let's try to find out what will be the value of acceleration. So here, acceleration is nothing but, or we can consider the average acceleration would be equals to change in velocity upon time taken. So we can take the average velocity divided by time taken would be equals to average acceleration. So this is the formula to find the acceleration or average acceleration. Since velocity is a vector quantity, so acceleration would also be a vector quantity. So this is the formula to find the average acceleration if they are asking to find instantaneous acceleration. So instantaneous acceleration would be equals to acceleration at a particular instant of time. So we can use a formula. Instantaneous acceleration would be equals to differentiation of velocity with respect to time, or dv by dt would be the formula to find the instantaneous acceleration. So let's see one example where there is a change in the position and velocity in only one direction, and let's see one more case where there is a change in more than two directions or one direction. So units will be known for us. For distance and displacement, units would be meters. For velocity and speed, units would be meters per second, and for acceleration the units would be meters per second square when it comes to SI. Okay, everything is fine. Let's try to see what would be the value of acceleration whenever they given some cases. Okay, let's see. We had a numerical where they given a position vector. Let's take the motion of the body is only in one direction such that x is given as t square minus 2t plus 1. So this is the position which it is varying only along x-axis and it is depending upon time as for this given case. In this question, we need to find what will be the acceleration. So find the acceleration at 1 second. So this is our question. Let's try to find it out what will be the acceleration. So if you want to find acceleration, first we should know velocity, because acceleration would be equals to differentiation of velocity with respect to time. So why we are using instantaneous acceleration means they given only one instant of time, so it will be comes under instantaneous acceleration. So to find the velocity, first we should know what will be the velocity by differentiating the position with respect to time. So velocity would be equals to differentiation of position with respect to time, which would be d by dt of x, which is t square minus 2t plus 1, which would be equals to 2t minus 2. So we got the velocity as 2t minus 2. Since I want to find acceleration, so a would be equals to dv upon dt, which would be d by dt of 2t minus 2, which would be equals to 2 meters per second square. So this is how you need to solve the numericals whenever they given position, or if they given velocity directly you can solve for it. Check it out. And let's try to see one more case, or one of the example most importantly. The idea is a particle is moving along x-axis such that x is equals to 2 minus 5t plus 6t square. What will be the acceleration of the particle when the velocity is equals to 0? So let's try to understand the case. They have been given the position where position is equals to 2 minus 5t plus 6t square. They are asking to find the acceleration when velocity is 0. We need to find acceleration when velocity is 0. So let's try to consider this condition. So velocity is equals to 0. So to find the velocity, we have a formula, that is velocity would be equals to differentiation of position with respect to time, which would be equals to d by dt of x, which is 2 minus 5t plus 6t square, which would be equals to minus 5 plus 12t. So we got the value of velocity. Since I mentioned velocity is becoming 0, let's equate this velocity as 0 such that 12t would be equals to 5. That implies t would be equals to 5 upon 12, means velocity is becoming 0 after 5 by 12 seconds. Here we need to find the acceleration when velocity is 0, means we need to find the acceleration when time t is equals to 5 upon 12 seconds. So let's try to solve. So here we got a velocity where velocity is equals to, so after differentiating the position with respect to time, we got the velocity where velocity we got it as minus 5 plus 12. So if you want to find acceleration, differentiate the velocity with respect to time, which would be equals to 12. You can see the acceleration is independent of time, means whatever the time interval you are going to consider, the acceleration is always same. So we can tell this is a condition for uniform acceleration where acceleration would be constant. So either at 5 by 12 seconds or at any time interval, the acceleration would be same, where acceleration would be equals to 12 meters per second. For example, after differentiating, we got acceleration depending upon time. Since we got at this particular instant of time velocity is 0, you need to put this value into that equation such that you can able to get the value of acceleration. So don't get confused for these sort of examples. Once make a practice and try to get it. Okay. Let's see one more one. The idea where velocity is a function of position or displacement. For example, so whenever the velocity is depending upon time, we got the acceleration as differentiation of velocity with respect to time. This was the formula we got. But in some cases, even velocity can also depending upon the position. Like v is equals to 2x minus 9, or velocity is equals to t square minus, or let's say depending upon position, right? So we can take x square minus x. So whenever the velocity is depending upon the position in this way, and they are asking us to find the acceleration, in that case we can find the value of acceleration as a, which would be equals to v into dv divided by dx. So this is the formula to find acceleration whenever velocity is depending upon the position. V into dv by dx. This is the formula. Try to check it out. We have an example also. Let's try to solve this concept with the help of example. So let's see. Here we have an example where they given velocity depending upon displacement, which is equals to x square minus s, where s is a displacement. Find acceleration when displacement is 1 meter. They given velocity as x square plus s. We need to find the acceleration when the displacement is 1 meter. So we can see here velocity is depending upon position. So in that cases, the formula to find the value of a would be equals to v into dv divided by dx. So since velocity is position of s, so in this example, acceleration would be equals to v into dv divided by ds. Let's try to solve. V into d by ds of velocity, where velocity is given as s square plus s, which would be equals to. So here v is a value which you can directly put here itself, or you can put later also. But since we need to differentiate the value of v with respect to s, first this is the term we need to do here. So it would be equals to v into, for differentiation of s square with respect to s would be 2s, and differentiation of s with respect to s would be 1. So it would be v into 2s plus 1. We got the value of v as s square plus s. So from here, a would be equals to v, which is s square plus s into 2s plus 1. Since I want to find the acceleration at 1 meter, so if you put the value of s is equals to 1 meter, then a would be equals to 1 square plus 1 into 2 into 1 plus 1. So 1 square plus 1 would be 2, and 2 plus 1 would be 3. So answer would be equals to 6 meters per second. So once try to practice with this idea also. Fine. So let's look into another concepts, projectile motion. Okay, before getting into projectile motion, it's very important for us to understand the motion in one dimension. So let's discuss that idea. And before going into it, we have a case, that is, if you have a position and if you want to find the velocity, we are doing differentiation like v is equals to dx upon dt. From velocity, if you want to find acceleration, again we are using differentiation where a is equals to dv divided by dt. If there is a case where they have given acceleration and asking us to find velocity, and if they given velocity, if they are asking us to find the change in position, let's see how you need to solve. For example, let's say we have a acceleration where acceleration is given as t square plus 1. They're asking us to find the velocity. So let's see what is the method that can be followed. So to find the velocity, we know the value of acceleration, and the formula to find acceleration is differentiation of velocity with respect to time. Since I want to find velocity, so a can be written in terms of velocity as dv divided by dt. So from here, dv would be equals to a into dt. So if you want to find the velocity, then you should do integration on both sides. So remember, when we do integration of dv, it becomes delta v, which would be equals to integration of a into dt. So from here, try to remember, on integrating acceleration with respect to time, we are going to get change in velocity. Not only velocity, we are going to get change in velocity when we are doing integration with respect. Similarly, assume we have a velocity and we need to find the position. So since we know v is nothing but dx upon dt, so from here dx would be equals to v into dt. Now if you do integration on both sides, integration of dx would be delta x, that would be integration of v into dt. So again, important point, On integrating v with respect to time, or integration of v into dt, we are going to get change in position. That change in position represents displacement. So try to observe, if they are asking us to find the displacement, then we should do integration of v into dt. So this is how you need to find it out, change in velocity and displacement if they give an acceleration as well as velocity. So let's try to do an example also, so that you will get a concept with an example. Let's say an idea. The idea is, so if an acceleration of a particle, if acceleration of a particle is given as a is equals to, let's take 2t plus t. So we need to find velocity. So we should find the velocity after 3 seconds. So we should find the velocity after 3 seconds. So we need to consider, they will mention initial velocity also. So if they given, find the velocity after 3 seconds if a body starts from rest. Means this point will play very important role. So we need to find velocity after 3 seconds if a body is starting from the rest. So whenever the body starts from rest, so whenever they mention a body starts from rest, means you need to remember the initial velocity of the body is always 0. Starts from rest means initial velocity would be 0. So since the body is starting from rest, initial velocity would be 0, and we need to find the velocity after time t is equals to 3 seconds. Let's try to solve it out. And most importantly, starting from the rest means when time t is equals to 0, initial velocity is also given as 0. So initial is nothing but time t is equals to 0. So since a body is starting from the rest, means when time t is equals to 0, the initial velocity is 0. We need to find the velocity after 3 seconds. So since they given acceleration and asking us to find the velocity, we can use a formula, a is equals to dv upon dt. Let's start from the basic points. So from here dv is equals to a into dt. You may also get a confusion, like if they give an initial velocity as 0, asking us to find final velocity after some time, why can't we use equations of motion? So remember the equations of motion, which I will discuss later, like v is equals to u plus at, can be used only when acceleration is constant. Whenever acceleration is constant, only in that case we can use this formula. But here acceleration is depending upon time. So since acceleration is going to vary, never use equations of motion whenever there is a variation of acceleration. That is the reason we need to use concepts to solve the numerical. So let's try to solve. If you want to find velocity, do integration on both sides. So since the variation is time here, they given when time t is equals to 0, the initial velocity is 0. When time t is equals to 3 seconds, we need to find the final velocity. So integration of dv, where velocity is varying from 0 to v, is equals to integration of a, where acceleration is 2t plus t, into dt, where time intervals are varying from 0 to 3 seconds. Now integration of dv becomes v, where the limits are varying from 0 to v. That would be equals to integration of 2t into dt becomes 2 into t square divided by 2, plus integration of t becomes integration of t. Oh, it becomes t. We can able to add, I guess. Or let's assume the numerical is like 2t square. Let's assume it is a 2t square. then it will make sense for better ideas. So if you consider 2t square plus t, then it would be equals to 2 into integration of t square becomes t cube divided by 3 plus integration of t into dt becomes t square divided by 2, because integration of x power n into dx would be equals to x power n plus 1 divided by n plus 1. Accordingly, we got these steps. Most importantly, the limits are varying from 0 to 3 here. So upper limit would be v minus, put lower limit as 0, which would be equals to 2 into upper limit would be 3. So take 3 cube divided by 3 minus lower limit is 0. So put t as 0 upon 3 plus, so upper limit is 3. So we can take it as 3 square upon 2 minus 0 divided by 2. It would be 2 into, so it becomes 9 plus 3 square would be 9 divided by 2. So it would be equals to 9 to 18 plus 9 divided by 2. So we can solve and we can get answer. So this is how you need to solve whenever they're given one quantity and asking us to find a different quantities. So when they're given position, if you want to find velocity, do differentiation. Again, if you want to find acceleration, do differentiation. But when you are going from the back, like from acceleration to velocity or from velocity to position, change in position, in that cases use integration. So this is an ideas where you need to follow, and let's understand the concepts when acceleration is constant. So check it out. Whenever acceleration acting on the body is constant, so we can tell it as uniform acceleration. In that cases, we can use equations of motion. Like final velocity would be equals to initial velocity plus acceleration into time. Displacement would be equals to ut plus half at square, and v square minus u square is equals to 2as. These were all the formulas you can use only when acceleration is constant, where v is final velocity, u is initial velocity, a is acceleration, t is time, and these are all the different terms where s represents displacement. Now, one of the important concepts in this idea is motion under gravity. Let's understand these ideas of motion under a gravity. Let's take, we have a ground, assume there is a body, we are throwing this body with some speed u. So this body can go upwards, reach some height, again the body would reach ground. So in this entire journey, there are some quantities which you need to find out, like what will be the maximum height, what will be the time taken to reach ground, and what will be the final velocity, and some cases. So whenever there are concepts from these ideas, there are some rules you need to follow. Not every question can be solved with the help of formulas. Sometimes you need to understand the concepts behind this. The main idea is, whenever you are solving the numericals from the motion under gravity concepts, the first point you should remember, the point of start, always take it as origin. For example, if you are starting from here, this point can be considered as origin. Or there will be some questions where there would be a building, assume this is a ground, there would be a building, assume this building has some height h, and let us consider we are having a body which it is thrown vertically upwards with some speed u, and this body may go upwards and fall towards the ground. In this example, since you are starting from here, so you should consider this point as a origin. The point of start, always take it as origin. Second important term you should remember, a vectors which is going up, take it as positive, and the vectors going down, take it as negative. Let's understand with these examples. In this example, initially we are throwing a body with some speed u vertically upwards. Since this initial velocity is going upwards, this initial velocity is taken as positive. Not always, I'm talking only for this particular example. Let's write the terms here only without any confusion. In this example, you are starting from here. Since you are throwing vertically upwards, so initial velocity would be positive. Then let's see. The vectors going down should be taken as negative. If you observe, the acceleration due to gravity is always acting downwards, and since g is also one of the vector quantity, since it is acting vertically down, so acceleration in this case can be taken as negative. Since acceleration is g, we can take it as minus g. In this example, initially we are throwing vertically upwards, so in this case u would be positive and acceleration would be minus g, because acceleration due to gravity is acting vertically downwards. But observe, in this case, we are throwing a body here, again the body came to ground. So once you are starting from here, again coming back to the same point, means assume we are throwing the body vertically upwards, again coming back to the same point. Without any confusion, just I made a separate line, but assume this body is also falling down vertically downwards, which would reach to the same point. So if initially we are at here, finally again the body come back to same point, so there is no change in the position. So in this example, displacement would be 0. But in this example, try to observe, initially we are starting from here, again the body has been reached to the ground. So initially you are here, now we came to here. So there is some displacement from initial point to final point, such that displacement is acting downwards. Since displacement is a vector quantity, in this example, displacement would be negative, and since the displacement from initial point to final point is height of the building, so displacement in this example becomes minus h. So very important conversions you need to remember whenever you are going to solve these cases. And one thing you should remember, whenever you consider at the maximum height, the final velocity is always equal to 0, or we can take at the maximum height, the velocity of the body is always equal to 0, because whenever the body reaches maximum height, the body wants to change its direction, means going from up again coming back to the initial point. So since the body is going to change its direction exactly this point, so whenever a body is going to change its direction, the body want to retard, want to be at rest, again the body want to change the direction. Immediately the body can't able to change the direction, so it will comes to rest, again the body will start to go downwards. So exactly at the point where the body is about to change the direction, in that cases the velocity is always 0. So in this example or in this example, the velocity of the body would be 0. So we can tell at the maximum height, the velocity of the body would be 0. So with these ideas, we are going to solve the numericals, and which would be helpful in getting the ideas also. So let's try to solve. Let's try to understand how we can use these formulas. So this is about the concepts when we are dealing with the vertical motion. Let's do the same thing when we are dealing with the projectile motion. In one-dimensional motion, the body will go only in one direction, like either upwards or downwards, or towards the right or towards left. But in projectile motion, the body has a position both along x and y. It can be z also. Even velocity can have more than 2 directions. Even acceleration also can have more than 2 directions. So let's try to understand how to deal these concepts whenever we are dealing with 2-dimensional motion. So here, projectile motion is nothing but the body would be moving in a plane. which would make some angle theta with the horizontal or it's vertical also. Let's assume it is a y coordinates. It would be an x-axis. Let's assume we are throwing a body with some speed u, which would make some angle theta with the horizontal. Now observe here carefully. So when we are throwing the body in a plane, it has some component along x-axis and the speed has some component along y-axis. So component of u along x-axis, let us take it as ux. Component of u along y-axis, let us take it as uy. Such that ux would be equals to, since theta is along the horizontal, so ux would be u cos theta and this component becomes u sin theta. Now again try to observe, whenever we are throwing a body, this body would move in a projectile path, precisely parabolic path. Now in this entire journey, let's try to discuss, is there any acceleration or not. First of all, since you are throwing the body with a uniform speed, means the speed is constant initially, but the time when the body has been thrown, it is going to affect due to an acceleration along y-axis, because acceleration due to gravity is acting vertically downwards, where acceleration is acting only along y direction, which would be equals to z. You can take direction as minus because it is acting down. Since an acceleration is acting on the body, it will affect the speed of the body, such that we can tell the speed is going to change along y direction because of acceleration acting along y direction. But if you observe, there is no acceleration along x-axis because there is no force which is pushing the body or pulling the body. But there is a force which is pulling the body vertically downwards, that is gravitational force, such that we have some amount of acceleration along y-axis. But there is no additional force which is acting along x-axis. So acceleration would be 0. Whenever acceleration is 0, the velocity won't change. So the velocity along x-axis would be uniform. So you should remember, the velocity along x-axis is always uniform, but velocity along y-axis is going to change. So these are all some points you should remember in the projectile motion. So our idea is to find what would be the equation of projectile. So whenever you are telling equation of projectile, make sure that that equation should consist of only x and y coordinates, means that equation should be independent of time taken. So let's try to solve. To find the equation of projectile, let's make a point. Assume the point is P. It's important to derive because this will help us to remember our concepts where we are going to solve in different cases. Assume this point is at a point of x comma y, where x is a length along x-axis and y is a length along y-axis. So this is the coordinates which is x comma y, where x is the length along x-axis, y would be the length along y-axis. Now let's try to understand what will be the equation. To find equations, since acceleration is constant, we can use equations of motion. Remember, whenever you're using equations of motion in 2 dimensions, take one direction separately, means x-axis separately and y-axis separately. So I am going to split these equations of motion along x-axis as well as along y-axis. So when you take along x-axis, if you observe, initially there is some velocity along x-axis which is u cos theta. So ux would be equals to u cos theta. And initially there is some velocity along y-axis. So let's take uy would be equals to u sin theta. And acceleration is acting along y-axis, which uy would be equals to minus g. Since uy is acting along y-axis, means upwards, so this value would be positive, but ay is acting down, so acceleration would be negative. So very importantly, you should represent all in terms of sign conversions. Since there is no acceleration along x-axis, so ax would be 0. So we can write here ax would be 0 and ay would be equals to minus. Now I want to write an equation in terms of x and y. Here x is nothing but displacement along x-axis, y is the displacement along y-axis. So let's use the displacement formula, that is s is equals to ut plus half at square. So since we are talking about x-axis, take displacement along x-axis, initial velocity along x-axis, and acceleration along x-axis. Don't take time because time is a scalar quantity. So since the displacement along x-axis is nothing but x, so x would be equals to ux, which is u cos theta into t plus half into acceleration along x-axis is 0. So this entire term would become 0. Similarly, displacement along y-axis would be equals to uyt plus half into ay into t square, where displacement along y-axis is y. Since the displacement is acting vertically upwards from initial point to here, so y would be positive. That would be uy, which is u sin theta into t plus half into ay is minus g into t square. So since the equation should not consist of time interval, so let's substitute the value of time t as x by u cos theta into this equation, where y would be equals to u sin theta into x by u cos theta plus into minus becomes minus half into g into x square by u square cos square theta. And if we solve, y would be equals to tan theta into x minus g by 2 u square cos square theta into x square. So finally we got the formula of equation of projectile. It's very important to remember, so try to remember this case also, which will help us a lot. Now let's try to see what would be the equations when we are dealing with the projectile. So let's consider we are starting from initial point. So initial point is nothing but point where we are starting our journey. So initially we are starting from here. So this is the point where time t is equals to 0. And we are throwing a body with some speed u, making an angle theta with the horizontal. So the body would move in a projectile path. Now initially we are here. Now finally we reach to this point. So in this journey we need to find three physical quantities. One is a horizontal range, one is a maximum height, one is time of flight. So here time of flight is nothing but time taken to move from initial point to final point. So this entire time is known as time of flight. First let's try to find it out, what will be the time of flight. So to find the time of flight, let's see what are the two quantities that we can able to use. First of all, let's split the physical quantities which we have been known along x-axis separately and y-axis separately. So if you observe along x-axis and separately along y-axis, in x-axis they given a velocity. So we can split this velocity along x-axis separately and y-axis separately, where the initial velocity along x-axis would be u cos theta and initial velocity along y-axis is nothing but u sin theta. Let's try to put the value of accelerations also. So acceleration along x-axis would be equals to 0. Acceleration along y-axis is equals to minus g because it is acting downwards. Now to find the time of flight, let's see which quantity or which formula need to be used. We have three formulas. Out of three, one would be suitable, and we need to verify which is a suitable formula. Check it out. We are starting from here, again coming back to the same point. Means out of this, one thing is sure, the displacement along y-axis would be 0 because initially we are at 0, finally also we are at 0 considering the displacement along y-axis. So one thing is sure, we got the displacement along y-axis as 0 when you are moving from initial point to final point. So displacement along y-axis is 0, in that case time taken would be time of flight. So you can see, since we are considering a displacement along y-axis, let's use the formulas considering displacement. So again we have two formulas. One is v square minus u square is equals to 2as. One is s is equals to ut plus half at square. So try to look at the approach, and this approach you need to follow for few examples, like eliminating the formulas which are not required. Now if you want to use the first formula, we should know the final velocity at this point, which is unknown for us. So better don't consider this formula. And this is the remaining. Displacement is known, initial velocity is known, acceleration is known, time we need to find it out. So this will be the suitable formula. So let's use this formula. So in this case, we have the formula Sy is equals to uy t plus half ay t square. Displacement is 0. That would be uy. Let's put as it is, into t plus half into ay into t square. So from here, half ay t square would be equals to uy into t. 1t got cancelled. So time of flight would be equals to, it would be negative, minus 2 uy divided by ay. This is the formula to find the time of flight. Remember in this form also, which will help us. Now if you put the values of ay as u sin theta and ay as minus g and u as u sin theta into this formula, then the time of flight would be equals to 2u sin theta divided by h. Remember in both the ways also, which are quite important. Now let's try to find the maximum height. To find the maximum height, so we have another formula which is v square minus u square is equals to 2as. Because exact at the maximum height, final velocity would be 0 along y-axis, because the body is going to change its direction only along y-axis. So exact at the maximum height, the final velocity would be 0. So if you use this formula along y-axis separately, so the maximum height is nothing but displacement from here to here, which would be equals to 0 minus, because final velocity is 0, initial velocity along y-axis, we got it as u sin theta. For time being, let's put as it is equals to 2 into ay into displacement along y-axis is nothing but maximum height. So the maximum height would be equals to minus uy square divided by 2ay. Now if you put the values, then the maximum height would be equals to u square sin square theta divided by 2. Just substitute the values of uy and ay, which we have been represented here, into that formula. We are going to get that formula. Now finally we need to find the range. Range is nothing but displacement along x-axis. So if they are asking us to find the value of range, indirectly we need to find displacement along x-axis. So since they are asking displacement along x-axis, so another, again we have two formulas, like if we need to use this sort of formula or this sort of formula. So try to observe, if you are using v square minus u square is equals to 2as, we don't know the final velocity here. So let's use s is equals to ut plus half at square only, where we know the time taken to reach from here to here as 2u sin theta by g. So we can directly get the value of range using this formula, s is equals to ut plus half at square. Now let's use the same way. Displacement along x-axis would be equals to uxt plus half axt square. So since the displacement along x-axis is nothing but length from here to here, which is nothing but range, so range would be equals to ux into t, where the value of t we got it as minus 2uy divided by ay. Plus half into acceleration along x-axis is 0, because there is no variation of speed along x-axis, which is nothing but 0. Now from here we can get the value of range as minus 2 ux uy divided by uy. Or if you put the values of ux and uy from this formula, like ux is equals to u cos theta and uy is equals to u sin theta into these steps, then the value of range would be equals to 2 u square sine 2 theta divided by g. So it would be 2 into u square into sin theta into cos theta, where 2 sin theta cos theta would be sin 2 theta. Accordingly, we are going to get this formula. So remember the formula for range, height as well as time of flight. Now one of the most frequently used formula, that is ratio of h upon r. Like they would be giving a relation between the maximum height and range. Like range is 2 times the maximum height, or the horizontal range would be 1 by 4th of the maximum height. Like what would be the value of angle theta, or what will be the initial angle of projection? In that cases, we need to relate the value of h upon r. Now we have h, which is u square sine square theta by 2g. We have r, which is u square sine theta by g. Do the ratio, we are going to get the formula as tan theta divided by 4. Very, very important formula. Very important, which has high importance. Now let's see an example. Most importantly, theta is the angle or angle of projection, especially along horizontal. So let's see one example. Try to remember all the formulas. So let's see an example with this. So here they mention the velocity at the maximum height is, the velocity at the maximum height of a projectile is root 3 by 2 times the initial velocity of the projection. Its range of the horizontal plane would be equal to. Observe the question carefully. The velocity at the maximum height of the projectile is root 3 by 2 times the initial velocity. Its range at the horizontal plane would be equal. Let's an example. So this is a projectile motion. Assume the initial speed is u. Assume the angle of projection is theta. Now the velocity at the maximum height. So this is a point of maximum height. You should remember, at maximum height, at this point, the velocity along y-axis would be 0 because the body is going to change its direction along y-axis. But the velocity along x-axis, which is u cos theta, always be constant because there is no acceleration along x-axis. So at every instant of time, the velocity along x-axis would be constant. So even though there is no velocity along y-axis, we have velocity along x-axis, which is u cos theta. As per the given case, the velocity at the maximum height. So the final velocity would be equals to u cos theta at the maximum height is equals to root 3 by 2 times the initial velocity. So here initial velocity is u. Let u be the initial velocity. This is a statement. So from here we can tell the value of u is going to get cancelled and the value of cos theta would be equals to root 3 divided by 2. Now its range would be equals to, we need to find the range. Now observe carefully. So we got the value of cos theta, which is root 3 by 2. So if cos theta is root 3 by 2, then the value of theta would be, oh sorry, the value of theta would be 30 degrees. Now we need to find the range. So since we know the formula for range would be u square sine 2 theta divided by g. Now we can put the values, that is u square into sine 2 into 30 divided by g, which is u square into sine 60 by g, where sine 60 is root 3 by 2, which would be root 3 by 2 into u square divided by 2. So this is the answer. Similarly, let's see one more example. This is a case where they given the velocity which relating the initial velocity with the velocity with maximum height. Let's see one more example where they give the relation between the maximum height as well as range. I think we haven't both. Let's frame a question by from our end. The idea is, if the range of the projectile is twice the maximum height, so find the horizontal range. So we need to find the horizontal range. If u be the initial velocity, so observe, they given a condition. The condition is the range of the projectile is twice the maximum height. With these two statements, we need to find the range. They haven't given what is the angle of projectile, and they haven't given at what a condition it is. So just the given relation between the range and maximum height. From here, we need to find what will be the range. So generally, if you want to find the range, we have the formula for ranges u square sine 2 theta divided by g. Means if you want to find the range, we should know the value of theta. To find theta, they given a relation between r and h, and these two formulas can be related by using the formula h by r would be equals to tan theta upon 4. So from here, h divided by r, which is 2h, would be tan theta upon 4 on cancelling h on both sides. So tan theta would be equals to 2. Now observe carefully. We don't know what will be the angle theta, because we don't have direct value to find the value of theta on equating tan theta is equals to 2. But I need to find the value of range. So in that condition, if you know the value of tan theta, I can get sin theta and cos theta. If you know sin and cos, I can find range, because sin 2 theta is nothing but 2 sin theta cos theta. So from here, r would be u square into 2 sin theta cos theta, because cos to sin theta will be 2 sin theta cos theta whole divided by 2. Now if you are able to find sin theta and cos theta, I can find the range. So let's see how to find it out. Now observe, tan theta is equals to 2, means tan theta is nothing but 2 by 1. So to get it out, let's assume we have a right angle triangle. Let us take it as theta. If tan theta is nothing but 2 by 1, generally tan theta is nothing but opposite side divided by adjacent side. So for this angle theta, it would be opposite, it would be adjacent side. So we can write tan theta as 2 by 1 as 2 and 1 from this triangle. Need not be 2 and 1, it will be 2 times x and 1 times x. Anyhow, on doing sin theta and cos theta, the value which you are going to multiply will be going to cancel. So let's take the smallest value or smallest possible values. So if tan theta is nothing but 2 by 1, so opposite side by adjacent side would be equals to 2 by 1. So since it is a right angle triangle, the hypotenuse would be under root of 1 square plus 2 square, which would be equals to root 5. So from here, I can find sine theta, which is opposite side by hypotenuse, which would be 2 divided by root 5, and cos theta would be equals to adjacent side by hypotenuse, which would be 1 upon root 5. If you know sine and cos, you can put the values here. So range would be equals to u square into 2 divided by g into sine theta, where sine theta we got it as 2 by root 5, and cos theta we got it as 1 upon root 5. So on multiplying these two, we can get the value of ranges 4 u square divided by 5. So this is one of the application on relating the maximum height in terms of range. So this is also one of the important applications. Once try to check it out. Okay, let's see another application which is known as graphs. So the ideas of graphs plays a very important role. So let's understand how to solve the numericals when we are dealing with graphical representations. So first of all, whenever we are solving numericals from the graphs, we should know the importance of differentiation and integration. Assume we have an x-axis and we have a y-axis. Let's take a curve. So for this curve, if I want to find the slope, so if you want to find the slope, first let us draw a tangent drawn to one of the point. So for this point, I need to find the slope. So let us draw a tangent. So here, slope is nothing but, generally we can find the slope as tan theta, where theta is the angle made by the tangent with x-axis. So if you want to find the tan theta, means if you want to find the slope in terms of x and y. So we can also find the slope by using the formula variation of y with variation of x, change in y-axis by change in x-axis. Or we can also find the slope by using the formula dy divided by dx. So this is the formulas to find the values of slope. So to find the slope, take the change in y-axis and as well as take the change in x-axis. So change in y by change in x, or differentiation of y with respect to x will give slope, or anything in the form of differentiation is nothing but slope. Again, if you want to find the area under the curve, for example, we have y-axis and x-axis. Initially, we are moving from point A to point B. So at point A, you are at position x1. At point B, we are at the position x2. Let's take x1 and x2 or some positions. Or we can take any points also. You are at x1 and you are moving to x2. So if you want to find the area, this amount of area. So if you want to find the area, we can use a formula. Area is equals to integration of y into dx, where the x is varying from x1 to x2. So observe carefully. Anything in the form of integration means we need to find area. Anything in the form of differentiation means we need to find the slope. So this idea will help us in solving the numericals, like finding the velocity in position versus time graph, or acceleration versus time graph, or finding the acceleration from velocity versus time graph. So in this graphical sort of applications, we can use this relation where y is the quantity along y-axis, dx would be the quantity along x-axis, and y would be along y-axis, x would be along x-axis. So these notations try to understand which will be used to find different quantities when it comes to conversion part also. So let's try to solve. Let's try to understand this all the cases. So the first idea is, let's understand position versus time graph. So when it comes to position versus time graph, let's take position is along x-axis and time is along, sorry, position is along x-axis, sorry, position is along y-axis, time is along x-axis. So we need to find what would be the variation when we are going to consider position versus time graph. Let's understand the first variation, that is I'm going to draw a straight line which is parallel to time axis. So what is the significance of this curve? Now observe, whenever we have a position versus time, from this graph what quantity can be found out? So the formula that can relate position and time is velocity, where velocity is nothing but differentiation of position with respect to time, which is looking like differentiation of y-axis with respect to x-axis. So differentiation of y-axis with respect to x-axis is nothing but slope. So from here, slope in position versus time graph gives velocity. So this is the significance of this case. So observe, in this example, let's see, the position of the body is not changing. Most importantly, slope is 0. So if slope is 0, velocity would be 0. So this is a condition where the body is at rest. There is no change in position. Let's see second graph. So let's consider this graph where we have position and time, and let's consider position of the body is increasing, or there is a change in the position. So we need to find it out what is the significance of this curve. Observe carefully, from initial point to final point we can see the slope of the body is constant, moreover the slope is positive. So this is a condition where the slope is constant and positive. Here slope is nothing but velocity, means velocity is constant. So we can tell this is a graph where it is said to be in uniform motion. So and velocity is also positive. So this is an example where the body is said to be in uniform motion. So whenever you look this sort of graph, this is an example where the velocity would be uniform. Or we can also tell this is an example of uniform motion. Let's see second or third type of graph. So let's consider we have a curve where it is going to change in this way. Let's take this as time, this as position. Let's understand what is the significance of this. So to understand, let's take any 2 points called A and B. So for point A, let's take a slope, and for point B, let's draw a slope. And if you compare, since you are moving from origin to this point where the slope of the body is going to increase. So compared to point A, point B has more slope. So we can tell the slope at point A is greater than slope at point B. So in position versus time graph, slope is nothing but velocity. So the velocity at point A would be greater than velocity at point B. Means when you are moving from origin to this point, the velocity, okay, slope you are dealing, right? Okay, slope at point B would be more than slope at point A. Like slope at point B is more because angle is more. Slope at point A is less. So velocity at point B is more than velocity at point A. Since the velocity is going to increase from point A to point B, we can consider this is an example where the acceleration would be positive, because acceleration is nothing but change in velocity by time, means final velocity minus initial velocity divided by time. Since final velocity is more than initial velocity, that implies A would be positive. So this is an example where we are getting an acceleration. Most importantly, acceleration would be positive for this case. And let's draw another graph where we consider position along y-axis and time along x-axis, and this would be the variation. So let's understand what is the significance of this case. So let's take any 2 points as point A and point B. So let's take a slope at point A and slope at point B. Since we are going to take a tangents such that we are going to find its slopes. So if you observe, slope for A is more than slope at B. Here slope is nothing but velocity for position versus time graph. So we can tell velocity at A is more than velocity at B. Since the velocity is decreasing from A to B, so whenever the velocity is decreasing, change in velocity would be negative. So acceleration is negative. So this is an example where the acceleration of the body would be negative. So try to check it out. So this is an example whenever they given position versus time graph. Accordingly, we need to find the significance of relating the velocities. So let's see another graph. It is velocity versus time graph. So here, on relating velocity and time, we can write two physical quantities. One is acceleration would be equals to dv divided by dt. Another case is, since v is equals to dx upon dt, so from here dx would be equals to v into dt. So if you do integration on both sides, delta x would be equals to integration of v into dt. Means try to observe this condition carefully. On relating v and time, we can find both acceleration as well as change in position. So since to find the value of acceleration, when you are going to consider velocity versus time graph, like a velocity versus time graph, assume there is a curve. So in this case, if you want to find the acceleration, we are taking the change in y-axis with respect to x-axis, which is nothing but slope. So in velocity versus time graph, slope gives acceleration. Similarly, to find the change in the position, we are doing integration. Like let us consider this is time t1. Let's consider this is time t2. From t1 to t2, we need to find the displacement. In that case, since it is in the form of integration, so area under the velocity time graph will gives change in position, which is also nothing but displacement. So this complete area will use displacement. This is the significance of finding the acceleration and displacement whenever we have velocity versus time graph. So let's try to understand what are the different types of velocity versus time graph. Let's take we have velocity and time. Let's take we are taking a straight line parallel to time axis. Now if you observe, from t is equals to 0 to t is equals to some value, velocity is not changing. Most importantly, slope is 0. So since we got slope is 0, in velocity time graph, slope is nothing but acceleration. So this is an example where the acceleration is 0. If acceleration is 0, we can tell this is an example of uniform motion. Let's see another type of graph also. So in this case, let's consider the velocity is going to change. Like let's consider we have velocity and time. Let's understand the velocity is increasing. So observe carefully. In this case, we can see the slope is constant and positive. So in velocity versus time graph, slope is nothing but acceleration. So in this case, the acceleration is constant and its value would be positive. But if you observe carefully, at t is equals to 0, the body has some velocity. Assume this is u and assume this is v. Means whenever they given a graph in this way, you should remember at initial time, means when time t is equal to 0, the body has some speed. So in this condition, a body or at time t is equals to 0, the speed of the body, or we can take the velocity of the body is u, means it has some initial velocity, means a body has initial velocity. Since the body has some initial velocity, so we can't take initial velocity is 0. If there are some numericals in this concept where they specified at t is equal to 0, it has some value, then you should consider the body having some initial velocity. Accordingly, you need to solve the numericals. Let's take another graph. The idea is we have velocity versus time graph or speed versus time graph, and this is the case. It can be negative also, but let us take this is the velocity versus time graph where the value is going to change. In this example, we can see the slope is negative and it is also a constant. So your slope is nothing but acceleration. So it is an example where acceleration is constant and negative. So try to check it out carefully. I'm not specifying whether the body is retarding or not. Just I'm telling acceleration is negative. Because don't try to think whenever an acceleration is negative, always the body is going to retard. In some cases, negative acceleration would be retardation or de-acceleration. But in few cases, even though acceleration is negative, still the body can accelerate. Let me give an example. Assume we have a condition of motion under gravity. So when we consider motion under gravity, we have an acceleration. So generally, whenever the body is accelerating, its speed will increase. If the body is retarding, speed will decrease. For example, if whenever there is an accelerating motion, in that case the speed increases. In retarding motion, or whenever the body is retarding, in that case speed decreases. But in this condition, whenever we are dealing with motion under gravity, let's assume it is a ground and there is a stone here. Assume we have a stone which is drop. Drop is nothing but initial velocity would be 0. But when we drop the stone from certain height, this stone will start to fall down. So whenever the stone is falling down, we can see the speed of the body increases. But we have saw acceleration due to gravity is always acting down. Whenever a vector is acting downwards, we took its sign would be negative. Means observe, even though acceleration is negative, the body is increasing its speed. So this is an example of accelerating motion. So here positive and negative will only tell the direction of the body. It won't tell whether the body is accelerating or retarding. That can be specified by understanding whether the speed of the body is increasing or decreasing. But the sign conversions like positive or negative will only tell the direction of the body. So try to check it out. Negative acceleration need not to be retardation every time. It can be accelerating body also, but you should understand whether the body is accelerating or retarding only by checking whether the body is going to increase its speed or decrease its speed. So this is one of the points you should remember, and it's very important also. Okay, we are dealing with graphs. Let's come back to the points of graphs. Till now we saw the ideas of velocity versus time graph. So let's try to discuss about acceleration versus time graph. Acceleration versus time graph. So let's take, we have a graph where the time is along x-axis and acceleration is along y-axis. And let's take one example. The acceleration is constant. So you can observe here the acceleration is not going to change where acceleration is constant. So this is an example where the acceleration is constant and positive. And this would be one of the examples which they will be mentioning frequently. Let's consider this is an acceleration and time. There would be this sort of graph. This is an example where the acceleration is constant and negative. So in acceleration versus time graph, this is a case where acceleration is constant and negative. But when it comes to velocity versus time graph, this is a case where acceleration is constant and negative. So this graph is similar to this graph. The ideas where acceleration is constant and negative can be considered for this graph, even for velocity versus time graph also. So try to compare. Like there would be some examples where you need to convert acceleration time graph to velocity versus time graph. So these sort of ideas will help you a lot. And from acceleration versus time graph, let's see what quantity can be find it out. Now to relate acceleration and time, we have velocity. Since a is equals to dv divided by dt, so from here dv would be equals to a into dt. When we do integration on both sides, we will get delta v is equals to integration of a into dt. Means this is in the form of integration. So anything in the form of integration means area. So we can tell the area under acceleration time graph gives delta v, means change in velocity. Here change in velocity is nothing but, for example, if you have acceleration versus time, if this is a graph, let's take this is time t1, this is time t2. If you do this area, so here area will gives change in velocity. Here change in velocity represents final velocity minus initial velocity. So remember, area under acceleration versus time graph will won't gives only velocity, it gives change in velocity. So one of the important term, because there will be some examples where they will tell initial velocity of the body is 4 meters per second, what will be the final velocity, and they will give a graphs. In that cases, use this idea, accordingly try to solve the numericals. So let's see one example. So in this example, the displacement versus time graph of a moving particle is shown. The instantaneous velocity of the particle is negative at the point. So this is a displacement versus time graph. So whenever we have displacement versus time graph asking us to find the instantaneous velocity. So to find instantaneous velocity in position versus time graph, we should find the slope. So slope in position versus time graph gives instantaneous velocity. So we need to find it out for which point the slope is negative such that we can able to find the velocity would be negative for that case. So for point C, if you draw a tangent, slope is positive, so velocity would be positive. For point D, draw a tangent, the slope is 0, so velocity would be 0. For point E, draw a tangent, we can see the slope is negative, so the velocity would be negative for point E. And if you take for F, again the slope is positive, so velocity would be positive. So we can tell, so for point C and for point F, the velocity is becoming positive because slope is positive, and for point D, velocity would be 0 because the slope is 0, and only for point E, the velocity would be negative because the slope is negative. So this is how you can able to find the cases. Let's see one more example. Which of the following graph for a body moving along a straight line is possible? We need to find which of the following would be the possible cases. Now observe the first condition. In this condition, the time is given along x-axis and speed is given along y-axis. We should find whether this graph can be possible or not. To check it out, let's take one time interval. So when you consider this time interval, we can see at same instant of time, this body has two different values of speed. At same instant of time, the body cannot have two different values of speed. So this is physically not possible. Let's see second case. It is speed versus time graph. So from time t is equals to 0, when you are proceeding, first the speed is increasing and then the speed is decreasing. Till here everything is fine. But below the time axis, we have a speed which is negative. If it was velocity versus time graph, this can be possible. But since here speed is becoming negative, which is not a possible case, so this is also not possible. Speed can never be negative, so this type of graphs is also not possible. Let's look into case number 3 also to verify whether this is possible or not. So let's take one time interval and let's try to see what will be the speeds at these two cases. In this example also, at same interval of time, the body has two different values of speed, which is not possible. So this is also wrong. Let's see case number 2. Here time is given along y-axis and position is given along x-axis, that can be varied accordingly. But idea is, when the time is progressed from 0 to some time, first the position is increasing and then decreasing, which can be possible because a position vector can be positive or negative, or it can be 0 also. But in this condition, from 0 it has some position, again came back to 0, which can be possible. And most importantly, time is also not repeating for same time, where it has two different positions, which does not have, or which does not have been shown in the question. Since I mentioned the time is changing from 0 to t and the position is also going to change accordingly, so this is positive. So if they have been given velocity, this would have been correct one. Since they given speed, this cannot be positive. So try to check it out this example. Let's see one more example. So here a particle is moving with the initial velocity of 5 meters per second in a straight line. If its acceleration varies with the time t as shown in the figure AT graph, then what will be the velocity of the particle at 7 seconds? So we have acceleration versus time graph. They're given a particle is moving with the initial velocity of 5 meters per second. So they mention initial velocity is equals to 5 meters per second. If acceleration is varying with time as shown in the figure, find the velocity at 7 seconds. So we need to find the velocity at t is equals to 7 seconds. Now observe, if we have an acceleration versus time graph, so we need to find what would be the value of v. Okay, I think it will be a meters per second square. So we need to find it out what will be the value of velocity. Whenever we have acceleration versus time graph, we know the area under acceleration time graph gives change in velocity. So we can tell, so if you want to find the change in velocity, we should find the area. Now observe, from 0 to 1 second, acceleration is positive. And from 1 second to 7 seconds, we can see the acceleration is negative. So when we consider the change in velocity, if acceleration is positive, change in velocity would be positive. If acceleration is negative, change in velocity would be negative. So we can consider this amount of area would be positive because change in velocity would be positive, but this amount of area would be negative because acceleration is negative, so change in velocity would also be negative. So let's find the total area. So it is a triangle, so its area would be equals to L into B, which is 1 into 5, which can be taken as 5. Let's take this amount of area. This area would be in the form of triangle, which is half into base. This is 1, it is 7, so the entire base would be 6 into the height. So the length from here to here is 8, so let's mention it as 8, which would be equals to 2 ones, 2 threes, which would be equals to 24. Now observe carefully. Since acceleration is negative, change in velocity would be negative, so we should take its area as negative. So total average velocity would be this area plus this area. So change in velocity means final velocity minus initial velocity would be a1, where a1 is given as 5. a2 would be negative because the change in velocity would be negative because acceleration is also negative now. Now to find the final velocity, so we can find final velocity minus initial velocity. Since initial velocity is 5, let's put the value of initial velocity as 5. That would be equals to 5 minus 24. So v would be equals to 10 minus 24, which would be equals to minus 14, and units would be meters per second. So option 3 would be correct. So they're asking from at 7 seconds, so we should find the entire area. But since acceleration is negative, take change in velocity as negative, so area would be negative, and this is the steps we need to follow. And if you won't consider this initial velocity, then the answer would become wrong. So try to observe carefully. Area will give change in velocity, not only the velocity. So this is one of the important terms you should remember, and don't do the mistakes for this cases also. So try to check it out, these applications. Then let's move into relative motion. So let's observe the main idea of relative motion. For example, most we have been observed whenever we are moving in a train. So let's consider we are in a train looking at the tree which is up. we can observe the tree is appear to be going backwards. But assume we have a train and there is a person which is standing on the platform. If that person is looking at the train is appear to be moving with some speed. Let's assume the same person who is in the platform, if he is standing in another train who is looking to another train. Let's draw with with the help of example. Assume there is a train A moving with speed 4 meters per second. Assume there is a person who is standing on the ground. So we can tell this train is moving with speed 4 meters per second. So the speed can be taken as 4 meters per second. Let's take the same example. There is a train A which is moving with speed 4 meters per second itself, and there is another train called B which is moving with speed 2 meters per second. We took very smaller values. Let's just understand the ideas and assume that person now is standing on this train B. Now if you observe the train A, now this train will won't be appearing with moving a speed of 4 meters per second. It is going to change. So how to find the velocity? So since a person is on B, so we should find the velocity of train A with respect to B. Look at the notations. Whenever you are writing VAB, this is nothing but velocity of A with respect to B. Such that VAB can be considered as VA minus V. So since both are moving in same direction, so velocity of A with respect to B would be equals to velocity of A minus velocity of B, which would be equals to 2 meters per second. But what is the significance of this condition? So whenever we are writing VAB, this VAB is also nothing but velocity of A looking from B. Means VAB is also nothing but velocity of train A if you are looking from train. That is the meaning of VAB. If you write VBA, means we are finding the velocity of B looking from A. So this is another way of understanding. But mostly used term of understanding the relative velocity is by concepts of frame of reference. Means whenever you are going to solve the numericals, we are in a frame where the frame of reference is always at rest. Means this person is at rest, means he is in inertial frame. Inertial frame is nothing but the frame of reference where the acceleration would be 0. If I am standing on the platform, so the acceleration of this platform is 0. So we can tell this platform is said to be in inertial frame. But let us assume there is a tree which is at rest, and let us consider we have a bus which is in the motion. Assume we are standing here. If you observe the tree, if you generally when you observe, whenever you are going to solve the numericals from the inertial frame, our frame of reference is said to be at rest. So when you are standing here and looking at the tree, we can assume that tree is at rest. But once you are standing on the bus looking at the tree appears to be in the motion. Tree would be at rest only, but assume you are standing in a train and moving in a train. When we observe the tree appears to be going back. So we need to find it out what would be the velocity of that particular case. Such a way, whenever the frame where you are standing, which is having some motion, that frame is considered as a non-inertial frame. So whenever you are doing in non-inertial frame, and whenever there is a concepts where you need to solve the numericals, such that you are going to use the concepts of relative motion. We are going to use this method, and the method is whenever you are finding the velocity of A with respect to B, that implies we are finding the velocity of A when the person B is at rest. That is the significance of using VAB in the concepts of relative motion. Means you are finding the velocity of A when B is at rest. Let's see with an example how you can understand these concepts. Let us take there is a car A moving along this direction with a speed of 20 meters per second. There is another car B which is moving in the same direction with a speed of 10 meters, or let's take 15 meters per second. I want to find velocity of A with respect to B. Generally, we can use a formula. Velocity of A with respect to B is nothing but VA minus VB, such that it would be 20 minus 15, which would be equals to 5 meters per second. That's completely fine. But when we are dealing with the two-dimensional motion, so the motion can be in x-axis as well as y-axis. So using these ideas will make you little confusion also. So what I can do is I am going to use this concept. VAB is nothing but observing the motion of A when B is at rest. So if you want to observe the motion of A considering B is at rest, so first we should make the body B at rest. But initially this body B is having some speed of 15 meters per second. So to make at rest, we need to subtract the speed of 15 meters per second such that 15 towards left and 15 towards right is becoming 0. Now B would be at rest. Since you are subtracting 15 meters per second towards right, this subtraction should be done, means this direction should be done for all the bodies. How many bodies we have? For all that bodies you need to take the same directions. Since we are taking a vector towards right as 15 meters per second, take the same value for A also, which would be 15 meters per second towards right. Now if I write A, now A would be equals to 20 towards left and 15 towards right. So if I take two vectors in opposite direction, resultant need to be subtracted. So 20 minus 15 would be 5 meters per second. Since towards left is more, so final velocity would be more towards left. Now when we take A, so when you take car called B, 15 left and 15 right, so net velocity would be 0. Now you can consider, if you are standing at car B, observing car A, the velocity of car A is 5 meters per second. So velocity of A with respect to B would be equals to 5 meters per second. Concept appear to be little lengthy, but it's very important to understand the concepts in this way. This idea is very important to understand these concepts, considering one of the body at rest and observing the motion of one body with respect to another. So check it out. Either you can use this method, but this method will help you a lot when you are going to solve the numericals in two-dimensional motion. So this is the idea of relative velocity. Once you can check it out, making one of the body at rest and subtract the motion in two directions according to this. One more example I will give. The idea is, assume we have a ground. Let's use this concept to solve a numerical. Assume there is a building. Let's take the building is at a height of 80 meters. Building is having a height of 80 meters. So we have a body A or stone A which is dropped, and we have another body B which is thrown with a speed of So let's take a speed as 40 meters per second. Now the idea is, if A is dropped and B is thrown up at same instant, our question is, when two bodies collide. So we should find when these two bodies are going to collide. So what is going to happen here is, this A is dropped. Since we know acceleration due to gravity is acting vertically downwards, this body will start to go down. And for this body, since we are throwing vertically upwards, this body would go vertically up. And since there is an acceleration which is constantly acting downwards, this body will start to retard. But at some instant, these two bodies are going to collide at one point. So we should find what is the time taken for collision. So whenever there are numericals where you are going to consider a collision ideas, better use the concept of relative motion. Let's see how. So if you want to find, there are multiple ways, but whenever using a normal equations of motion, first we should assume one time, or we should assume one of the point, use equations of motion for first body and second body, and you need to solve, which would be a bit lengthy. But if I use the concepts of relative motion, the same numerical can be simplified within few steps. The idea is, I am using the concepts of relative motion. Here two bodies are in motion, we can't able to use the equations of directly. So what I am going to do is, I will make one of the body at rest. Make either B at rest or either make A at rest. That is completely our choice. Now let me draw the cases here once again to understand the concepts of relative motion. So here we have a body A where initially its velocity is 0, but there is an acceleration which is acting vertically downwards, which is g. For body B, there is a speed of 40 meters per second which is acting up, and acceleration is g which is acting down. So there is a motion for two bodies. Let's make one of the body at rest. To make one of the body at rest, that's our choice, either make A at rest or either make B at rest. So what I am going to do is, let me assume A is at rest. Let us make A at rest. So initially A is not at rest because due to some acceleration, A is also going to move. To make A at rest, the acceleration should be 0. Now since some acceleration is acting down, that much amount of acceleration I am going to take upwards. Since you are taking A upwards, same amount of G take for this body also. Now G down and G up, the net acceleration would be 0. And G up and G down, in this case also net acceleration is 0. Now when you are going to solve the numericals from the concepts of relative motion, now we cancel the net acceleration. If there is no acceleration, then this body would be at rest only. There will be no motion for A. Now B want to collide. If B want to collide, so initially B has some speed. With this speed, the B will start to go upwards and collide A. So to collide from B to A, it need to travel some distance. That distance is nothing but height of the building, which is of 80 meters, because A is at the top of the building. So distance need to be traveled to collide A should be 80 meters. So since there is no acceleration, we can use a formula. Speed is equals to distance divided by time. Here speed is 40 meters per second. Distance traveled is 80 meters divided by time. So from here time t would be equals to 2 seconds. Means after 2 seconds the body is going to collide. We can solve this numerical with the logic applying the concepts of relative motion. Like whenever there are two bodies which are in motion, make one of the body at rest and use these concepts to solve the numerical. So these are all the ideas from the concept of kinematics, and do well for and all the best.